I would like for you to write the equation of these functions. Okay, we learned yesterday how to move things. Do we remember this? Moving things? Yes? Okay, so I'm actually going to go a little bit out of order here so we can remind ourselves of what we did, and then we'll go back and do these. Yesterday we talked about changing these things, and it's called a transformation. Does everybody see that bolded at the bottom of your page there? A transformation. What's up, Luke? Okay. Transformation is change. Guys, if you transform something, you change it. Okay. Now, specifically, a translation is what? To move it. And yesterday, I think I used the word slide a little bit. Okay, we're going to slide it. Which direction is vertical? Up and down. So if I want to move it up from yesterday, what is the indication that something has been moved up? Correct. And where will the number be? Is that the part that's inside the parentheses or on the end? On the end. So this will be x squared plus some number, and that's going to move it up. Well, then, how do we move something down? Yeah, x squared minus something is going to move it down. Everybody doing all right here? Okay, so what direction is horizontal? Side to side, left and right. It's the opposite. Okay, so he's telling me the right is negative, but where? This was on the end. Where do I put these numbers if I want to move it to the right? In where? Not in the front. Where do I put it? Inside the parentheses. Okay, so Dalton is correct when he says we do the opposite. So for the right, it's going to be subtracting something inside the parentheses. And then to the left, it's going to be adding something inside the parentheses. So there's two things you need to remember. Up and down gets put off to the end. Side to side gets put in the parentheses. Everybody good? So let's go back and let's do our warm-up now. I want to know the equation of this parabola. If I want to do that, I need to know where the vertex is. So tell me, where is this vertex? Was it moved at all? No, that's 0, 0 is where we start, yes? So, do I need to put any numbers inside the parentheses or off to the end? No, I don't. It's just y equals x squared. This is the base model. This is the parent function. Remember us talking about this yesterday? There's nothing around it. It's just x squared. Okay. How about this guy? Where's this vertex? Wonderful. So did it get moved? Where? Down to. So if we move something down to, does that go inside the parentheses or off to the end? To the end. So it's going to be y equals x squared. And then if I'm moving down to, it's minus 2. Everybody following along okay? All right. How about number 3? What's my vertex? Okay. So did it get moved? Yes. Where did it get moved? 3 to the left, which means that's going to be inside parentheses. Hold on a second. I'm going to get the up one in a minute. If we're going to the left, is that going to be plus 3 or minus 3? Plus 3, and it gets squared. And then like Dylan said, it'll be a plus 1 because we moved up 1. Please remember, left and right is the opposite of what you think. Up and down is exactly what you have here. Okay, moving on. We are going to the right 2 because my vertex is at 0 or 2, 0. So, what's my equation going to look like? Do I need anything off to the end? No, because I didn't move up or down. It's patterns here, folks. Lots of patterns. Number 5, my vertex Oh, flip it around there for me, Logan. There you go, 3, -1. So if we go to the left, what does that mean? We're not plussing 3. It's going to be x minus 3. -1. Yep. Okay, and last one here. Where's my vertex? 2, 3. So where'd we go? So how do we show left 2? Oh, that's not left 2. Right 2. Right 2. So x minus 2, and that gets squared. Then plus the 3. Perfect. Okay, so that should be all review from yesterday. Everybody doing all right? Now, that's not the only way that I can change the shape of my parabola. Okay, we have some other ways, and we're going to talk about that. We good? We're going to talk about that on the back. Another way that we can change a parabola is a reflection. What's a reflection? The same, but on the other side. Okay, the word that I like to use is flipped. Mirror image, yep, that'd be the same thing as well. Now, we already know how to flip a parabola because normally, and you don't need to write this, normally parabolas look like this, yes? How do I flip them so they look like this? The beginning one becomes negative. So if I want to flip it, I just have to make it a negative x squared. That's all. And you already knew that. Okay, we already talked about that. Lastly, we're going to talk about a dilation. This is a change in size. Kind of like a scale factor. Not quite the same, but similar. Okay, so you guys all know what silly putty is, right? What happens when you stretch silly putty? What it gets very thin, doesn't it? Okay, so when I say I'm going to stretch something, it is going to get thin. It's going to get thin. Now, how do I do that? Well, in my equation, I'm going to put some number in front of the x squared. And that number either has to be bigger than 1 or it has to be less than -1. And it's going to stretch it out. I'm going to show you what that looks like here. All right, so my parent function is y equals x squared. Everybody's good with this, right? We've seen this about 100 times now. Agreed? I want to stretch it. I want to make it thinner. What do you think? Is that blue one thinner? Is it skinnier? Yes, because of this 4 in front of the x squared. Does that make sense to you? Now, normally, for our parent function, for the next point, we go over 1 up 1. Yes? The red one is over 1 up 1. Look at the blue one. It's over 1 up 4 because of that 4. What if it was a 10? Does this make sense to everybody? What if it was a 2? Good? The bigger that number is, the skinnier it's going to get. Let me show you. Let me change this to a y equals 10x squared. Even skinnier yet, right? How about y equals 25x squared? Skinnier yet? What if I go to y equals 2x squared? Now it's in between the regular one and the 4 one, right? You see how we can kind of, yeah. Correct. The negative just makes it upside down, but skinnier. So, for example, if I put a negative in front of here, now it's upside down and skinny. If I put a negative in front of here, upside down and skinnier at the same time. Yep. Okay, so that is making it thinner. Now let's talk about compressing it. Think about Play-Doh. What happens when you compress the Play-Doh? It gets flatter and wider, doesn't it? Okay, so a compression will make something wider. Another example that I used in fourth period was, what do you do with a hamburger when it's too big for you to take a bite out of? You smush it down. Oh, yeah, but you smush it down so it becomes wider, right? Okay, so that's the same idea here. In order for me to achieve that, I will also put a number in front of the x squared, but this time that number has to be between -1 and 1. Now, automatically, when I said this fourth period, they said, oh, 0 is in between there. Well, yeah, you're right. 0 is in between there. But what is 0 times x squared? And you won't even have a parabola if it's just 0, will you? No. So how about a half? Is a half between -1 and 1? Let's see what that looks like. Y equals 1/2 x squared. Oh, hold on a second. Did it make it wider? Yes, it did. What if I make it a smaller fraction? Can you give me a fraction that's smaller than a half? 0.5 is a half. 1/3? Let's try 1/3. Now you said 1/3 was smaller, right? That's going to make it wider yet. Give me something that's even smaller than a third. A tenth. It's going to make it wider yet. Everybody see that? Yes, are we sure? Now, do you remember how I showed you how in the parent function it was over 1 up 1? Right there, yes? Well, let me show you what happens here. For a half, we go over 1. How far does that look like it went up? A half. So what if it was a quarter? It's going to go over 1 up a... Okay, can you please keep track of your pencil? That's about the 5th time you've dropped it today. Is this all jiving logically with you? Does it make sense to you? Good. All right, so let's try some of these. And I'm going to try to show them to you visually so you can kind of see what's going on. First one, I need to know what happened to this graph. Did it get stretched, compressed, flipped? Did it move up? Did it move down? What happened in number 1? Does everybody see this 2 right here? That means it is stretched by how many? Is there anything else attached to that function that would change it at all? Not at all. What is going on? Okay. Pay attention. Covering your eyes is not getting you what I'm trying to get across. What happened in number 2? How do you know that? Okay, does everybody see the 1/3? Does everybody agree that 1/3 is less than 1? Okay, so that means it's going to be compressed. By how many? By 1/3. Whatever that number is. Now there's something else that happens here. Yeah, that negative does what to it? It flips it. Now the mathy word for that is a reflection, so that's what I'm going to use. So 2 things happened. We got compressed because of the 1/3, and we got flipped because of the half. We souped it up a little bit. Gave it some leather seats and a moonroof. So, do you understand the analogy? Okay. Number 3. What's happening? Oh, which one is it? 2/5 is less than 1. Yep. I would rather have a whole pizza than 2/5 of pizza, right? Okay, so 2/5 tells me it is compressed. Is that going up, down, left, or right? This guy right here, off to the end, tells me up by 4. Perfect. Okay, I want to show you this one, please. Y equals 2/5 x squared plus 4. Take a look. First of all, did it get moved up? Yes. Second of all, is it wider? Perfect. That's exactly what you told me was going to happen, those 2 things, and it did. Okay. Number 4, this is not in the correct form. So what is the correct form? Wonderful. So can you now tell me what would happen? By how many? Stretched by 4, so this is going to be thinner. This over here, there you go, up 7, and this guy right here tells me reflected. 3 things happen this time. Negative 4x squared plus 7, let's see what it looks like. Y equals negative 4x squared plus 7. Did it get flipped? Did it get moved up? Yes, it did. Is it thinner than the original? All 3 of those things happened. It's not just made up stuff here. It actually works. It actually is happening. Okay. Number 5. What happened? This right here tells me compressed. She thinks left. What do you guys think? This is inside the parentheses, so it has to be left or right. And plus 4 is left 4. Wonderful. All right, how about a number 6? What happens? This tells me reflected. This right here tells me the right 2. Questions for me, guys? Is that a no? Okay. So tell me about number 7. We got a lot happening in number 7. This tells me up 5. What else? This tells me, and then right 3 because of that. Wonderful. Now, everything possible that could happen to a function is happening in this next one. The most you can ever come up with is 4 things happening. This tells me reflected. Now, is it stretched? This is less than 1, so it's going to be compressed. But it's really not compressed that much because 2/3 is relatively close to 1, isn't it? So it's just going to be a little bit wider. This tells me left 1. And this over here tells me down 7. Good, right? Easy stuff. Okay, the last thing we're going to do with this is we're going to match them up. You see down at the bottom, you have a set of graphs. You also have a set of equations. I want you to match the graphs with their equations. Now, the best way to do this is a process of elimination. Okay, so I want you to take a look at those graphs and tell me where you want to start. Why do you want to start with B? What is the movement in B? It's definitely up 4, which means I have to have a plus 4 where? Where do I have to have the plus 4? On the end, correct? Do you all see this plus 4 over here? Do any of the other ones have plus 4s? It has to be that one. Okay, so this is B. Now, the other thing you want to notice here, does everybody see this 1/3? Does that 1/3 mean skinnier or wider? Is this wide? Yes, it is. Okay, 1 down. Where do you want to go next? So this is letter B. We're done with this. Where do we want to go to C? I don't really care where we go. What's the only other wide one? C. So we know it has to have, it's got to have a 1/3. Okay. Did it get moved at all? Down 4. So I need a 1/3. How come it's not 19? Yeah, the only thing that's happening here is moving down and wide. Over here, we have another move, don't we? So this one has to be C. You're right. Yeah, because it goes down 4 and it goes to the left 4. Yep, so we're at A. So far we've eliminated the whole top row. Why does D have to be 21? It's reflective. Oh, hold on a second. I got 2 other reflectives. D has to be negative. We know that. Which has to be 21 or 22, correct? Which one? 20. Hold on, I want to answer your question. These two are both being reflected, aren't they? So you have to make the distinction. Which one is which? This guy is also shifted up, so I need the one with a +2. Which one has the +2? Yes, so this is D right there. Well, that tells me what the other one is then, though, right? F has to be 21, and that leaves me over here. Now, there is a typo in this problem, so I need you to fix it in case you might happen to come back and look at it. Do you see how number 23 is shifted down? This equation over here says it's up with the plus, doesn't it? Can you make this a minus sign for me? And that would be letter E. Okay, so kind of doing a little bit of matching there. Yes. There is, but you shouldn't. You should finish it in a matter of about 7 minutes, I would think. Homework. Oh, you guys just need to get along. That's all there is to it. Here you go.